Hi, I'm Orit Nissan-Messing. I'm the chief architect at Iguazio, and I'm here to talk about AI and serverless. So I know I stand between you and lunch, so I try to keep it short. And if you have any more details that you want to hear, come afterwards to our booth. So what companies try to achieve from an AI solution? They want to have an immediate insight from the moment the event has occurred to the time that it taken to take an action or to understand something has happened. They want to have smarter decisions to take fresh data correlated with historical data and use it with the AI model that they have. Usually, in many use cases, a single event has no meaning. It has a correlation with the other events that happens simultaneously to that event or within the same time frame that gives it a meaning. For example, if you think about cybersecurity, a single event doesn't mean you're threatened. It's when you take into account the events that occurred within this short time frame, then you understand that you need to take an action. So you need to enrich data of events as they come into your system. You need to enrich them from other data sources. You need to do some computational logic on those events to accumulate them. And it's very natural to do this with a serverless. Another thing that companies want with an AI solution, but actually with any solution out there, everyone wants the cloud agility, the cloud experience, to be able to test their code and integrate it with the new and deploy it very fast to get to a production pretty quickly. So serverless brings that pretty naturally. So we're all here in a serverless conference, so there is no really need to let you know what's the benefit of serverless. It lets the developer focus on the business logic and let the serverless framework worries about anything else, the scalability, the availability, the upgrades, all those kind of stuff that we usually use to take care of them, the framework takes care for you. But is it really appropriate for an AI mission? Can it be integrated with an AI solution? What's the issues with that? So usually when one thinks about serverless, he thinks about the trade-off. There is the ease and convenience of the serverless, the idea that you can go into production pretty fast. But there is also a cost to that. There is the penalty, there's the latency between the time that event is coming to your system and the time it takes you to run the code and get an insight out of it. There is the concurrency of that. How many events can you really handle in a second? If you think, for example, on an IoT solution, the number of events that will be received to your system are thousands and hundreds of thousands of events for a second. You need to be able to process all of those events in a real-time kind of a manner. It's not a real-time in the sense of a nanosecond kind of real-time, but it's a real-time in those kind of use cases. Another obstacle that there is with many of the serverless frameworks is the type of event sourcing that you can get. Mostly use HTTP. Some use Kafka and other streaming events. But when you think about IoT sensors or a mobile device that sends its output, HTTP cannot conquer all. So we need much more event types. We need message queues, RabbitMQ, MQTT, Event Hub for Azure, Google PubSub, Kinesis. There are many Kafka. There are many event sources that you want to be able to receive your events out of. So given the need, and we are building Iguazio is building a data platform, a continuous data platform for an AI application, an event-driven application. So given the need for our customers and the lack of the framework currently out there in the market, we open source Nucleo. So Nucleo is an open source project opened a few months ago in GitHub. I encourage you all to go and get a look at that. It provides many benefits, but the three main ones, first of all, it's the performance. It can run 400K of events, like Hello World kind of events, but still, in a second with a sub-millisecond latency. So now you can have your IT sensor being pushed in just thousands. Oh. Thank you. Hope it won't come back. So now you can have your IT sensors ingest thousands of events to your system and to be able to enrich them with information and accumulate them to your system. It supports many triggers. It supports Azure Event Hub and Google Apps Hub and Kinesis and Kafka and HTTP requests and a cron. There are many, many event triggers that it supports. So we now are not confined to a specific cloud provider or specific use case. You can combine many different methods within a single function. And you can have your code function once. So you write your code, and the same code can be run with different type of event sources. It can receive different type of event sources at the same time. And it can run on any platform. It can run on a Docker container on your laptop, but that's not an AI mission kind of a thing. But it can also run, it's already integrated with GKE. It's integrated with AKS. You can run it on a Kubernetes clusters. And you can combine those, so you can run different nuclear functions on a different kind of a cloud vendors. So even though nuclear has been released, just stop working, sorry. Let's go to the old method. Gotcha. Even though it's just been out for a few months, it's already got a lot of traction on GitHub. There are many stars, and there are some impressions from the Kubernetes gods, may I say, from Kelsey Hightower, which is Google development advocate, and from Brandon, which is one of the Kubernetes founders. So I really encourage you to go into GitHub and take a look at Nucleo. It's really, really simple to start working with that. And it's free. So I'll try to go over 2 use cases, and if the time permits, I'll go into the third one. The first one is of predictive maintenance. It's a use case where there are machines on a factory floor sending their telemetry information every 5 seconds. And there are error events that the machine may trigger. It doesn't mean that the machine is broken, but it suffered some kind of an error. What we wanted to achieve here, the customer wanted to achieve in this case, is to be able to predict whether the machine is going to be failed or not in advance, and to replace the failed component in advance before the factory is being shut down. So in this specific use case, we used Azure, a machine learning workbench, that took historical data for over a year from the factory and have trained a model out of it, considering what will be considered as a failed system. So we took that model and moved it to our intelligent edge, running as a Kubernetes Docker on the edge. So now we have the device sending its telemetry information, and we have a Nucleo function taking this information and aggregate it into a data layer, which in that case is our own system, but it could be on any data platform that has these capabilities. Aggregate this information into buckets. So then a later function, which will run every once in an hour, will take the model, will take the information that is being needed, the needed standard deviation and mean and max and all those kind of thresholding, which is by the model what it requires, calculate the last 12 hours, 24 hours, 36 hours of those sensor information and send them back to the model. I forgot to mention, sorry, that the Nucleo function for the sensor data processor is mostly aggregating data, but if something passed a certain threshold, which is out of scope, it could trigger an alarm at that moment instead of waiting for the windowing of the 12, 24 hours, 36 hours. At the same time, there is a third function, which is used to sync information back to the cloud. So that function, the third one, is actually 2 different functions. There is a function to get the model. The trained model may have a new model on the cloud, then to bring that on-prem. And the second kind of sync with the cloud is the other way around. So we have all this new telemetry information that we didn't want to send each one of those events to the cloud. But now that we have a day work of telemetry events, we can now send them, push them to the cloud. So there is a third cron job of a nuclear function that take this information and send it back to the cloud. So, and I'll show a video for this demo. This demo is a demo that developers from our system, from our company, developing in a hackathon held for 1.5 days. Several developers did that. And you can see with that with serverless, stuff that usually took months to develop are pretty easy to develop, since all the other infrastructure are being taken care of from the serverless framework, so you don't need to care about the scalability and all those kind of notions. So what we see here is a demo of a ride-hailing kind of a use case. We have several customers that have this kind of a use case. There is the driver application that sends when you take a ride, when he did a drop-off. And there is the GPS location when the driver is being located at every moment in town. It's been enriched with information from a Google map. It could be, in some cases, as we've seen customers, be enriched with weather information. So all this information is coming ingested using Nucleo to enrich the data into a NoSQL data layer. At the same time, simultaneously, you can run a Spark job. Spark is a pretty known framework in AI. So the Spark can do trending analytic. To do, if on Sunday at 1 o'clock there is a lot of demand for cabs, so I can request a higher price when there is a ride coming, and that kind of a trending. And in real time, you can have someone to talk to the system, and what they demo here is something pretty nice, is someone talks to a Google Home device, and Google has the dialogue flow that converted to a text, and a nuclear function that takes the text and convert it to a SQL query. And then we have Presto, which is another framework which is very known in the AI world, which is stateless one, and it's an interactive SQL query. So Nucleo invoke, take the text, invoke it into a Presto SQL query, and to the system itself. Everything here can work in parallel. The serverless, it's not really anymore a pipeline. So I'll show you the video. I think the movie talks better than...
Show me some cars. There are 1383 drivers in Phoenix right now.
Can you hear it?
How many of them are busy at the moment? 412 of 1384 drivers are busy at the moment. That's 29% of them. Can I see the list of drivers? Here they are, starting with Ruby Naquin. What about our income totals in the last week? Looks like you made the most bank on Sunday, with around 18,600 bitcoins. And how much on average did this cost each customer? Here you go.
So before I move to the next use case, what's important to show here is that with serverless, it's not only serving the data, you can also use it for ingestion, for enriching. So you have multiple kind of ways to use the same serverless capabilities as a cron, to do something in the background every once in a while, to serve your data out, or to ingest it. So last quick example is surveillance. In that case, someone took an image, sent it to a Nucleo that did an encoding out of it and save it to the data platform. You can then do triggers, a Nucleo function that can run over in simultaneously to the entire pipeline. You can have a TensorFlow service that use image detection and say if this person you think is as a suspect, and tag the picture as a suspected person. In parallel, for creating an event of found a suspected person, a Nucleo function could be triggered to call the police or something on that like. You can have a Presto or Spark and at the same time querying, give me all the suspected people, give me all the people that were connected to that people, and all those kind of AI kind of queries to the system itself. So Nucleo is pretty easy, and I didn't show you how the dashboarding and all that installation is working, and it's pretty easy, very convenient, and I urge you to go in GitHub and take a look at that. Thank you.